Oh my God, I like you guys so much that I'm doing this on my holiday, posting all of the answers to the test you were supposed to have written, but because most of you asked me so many questions, it drove me crazy. I'm going to actually go ahead and give you all the answers to the actual test you wrote today. Our first four questions were true-false, and you're supposed to show work. Now, instead of just listening to the answers passively and just saying, oh, okay, that's what I was supposed to do, just make a note and just make a little thought bubble and a little post-it note right over top of it. What is the mistake you're always making? And just write it on a post-it note or something and just remind yourself what you should be doing instead of what you did do, right? It's important that you do that, reflection. The first question says 2 squared minus 3 squared plus 4 squared plus 1 squared is equal to 8, true or false? So obviously what we're going to do is we're going to solve it, and 2 squared is 4. 3 squared is 9, because we know that when you square a number, you multiply it by itself. 4 squared is 16, and 1 squared is not 2, it's just 1. So if this equals 8, then the answer is true. So 4 take away 9 is actually negative 5. If you said 5, we're in trouble. But anyway, negative 5 plus 16 is 11, and 11 plus 1 is 12. And since 12 does not equal 8, your answer to the first question is false. Now, please pay attention. You can't just say false, because there's a whole lot of freaking work there that you had to show in order to prove that you knew that it wasn't equal to 8. So please make sure you make a note of that. The second question says the square root of 16/25 plus the square root of 1/9 is greater than 1. So obviously we need to know what the square root of 16/25 is. So what you were told to find the square root of fractions, it's real easy. You say what fraction multiplied by itself was 16/25, piece of cake. Once you write that down, or once you think of it that way, we know the numerator is 4, because 4 times 4 is 16, and 5 times 5 is 25. So therefore, this square root, the square root of 16/25, is equal to 4/5. So therefore, I can write down 4/5. Plus the square root of 1/9, what fraction times itself is equal to 1/9. Numerator is 1, denominator is 3. So therefore, that is the square root of 1/9, which I will write here, 1/3, like so. And really, if I break down the question, once I calculate my square roots, that's really the question, right? This is now a grade 7 question, or a grade 8, whenever you learn how to add fractions together. It's now no longer grade 9 worthy, it's now grade 7 or 8 worthy. Adding fractions requires a common denominator. Equivalent fraction, we know how to make those. We've done them many, many times before. Equivalent fraction of 1/3 is 5/15. Once we have that written down, we're going to add our numerators and keep our denominator. Our answer will be 17/15. And at this point right now, I have enough information to gauge whether or not it's true or false. 17/15 is greater than 1, because actually technically it's 1 2/15 if we wanted to really get technical. And therefore this is greater than 1, and therefore our answer to the question is true. Now there's a lot of stinking work you had to show for that question. If you're not showing all of this work here, right, you're missing the boat as to what you need to do to prove whether it's true or false. Question 13, a little tricky, but not really. It says 12.25 is a perfect square. The square root of 12.25 is a perfect square. So if I was to say, well, the square root of 12 and 25/100ths, that's the same question. So this question highlighted in yellow. Oh, sorry, that's not highlighted. This question and this question are the exact same thing. One is a rational number in decimal form. One is a rational number in mixed fraction form, both rational numbers. But if it was me, and this is just me, because if I was thinking this question through, I would definitely say, you know what, I don't want to work with 12. I think if I wrote this in the lowest terms, I think that's probably an easier question. So before I even start, I could have done this one. Because the rule is if you are calculating the square root of a decimal, or if you're calculating the square root of a mixed fraction, both are impossible to do, or very difficult to do. I shouldn't say impossible, are very difficult to do. But if you treat it as an improper fraction or just a proper fraction, it's much easier. If you change this fraction to an improper fraction, it becomes a little complicated, because 100 times 12 is 1200. You'd have 1225 over 100, which is not really, really easy to work with. You could do it, but without a calculator, you're not quite sure what 1,225, what number times itself is that number. But if you did use this in lowest terms, it's so much easier. 4 times 12 is 48 plus 1. Really, this mixed fraction as an improper fraction is this. And once you have that written, instead of 12 1/4, it's 49 quarters. This one is the best one to solve because now I know that it's 7 as my numerator and 2 as my denominator. So therefore, the square root of this is 7/2. The square root of it as a mixed fraction is 3. What's 7 over 2? 3.5 as a mixed fraction. And if I go back to my real decimal question, my original question was 12.25. What is the square root of that? It's 3.5, right? So is it a perfect square? Yes, it is. And the square root is 3.5. A lot of work, but again, I'm asking you to really dig into your understanding of what square roots mean. And the last question says 0.9 squared. 0.9 squared is 0.9 times 0.9. And we said that when you multiply rational bases or rational numbers by themselves, the easiest way is to think of just 9 times 9, drop the decimals and get 81. And then whatever the number of decimal places you had in your actual squaring, in this case 1 decimal place, you double it, which is 2 decimal places, and you add 2 decimal places to your answer, making it 0.81 as your answer. Okay? So since 0.81 is not greater than 1, we say this one's false. That's one way you could have done it, is just multiply the decimals like that to get your answer 0.81. Another way, if you really don't like it, since 0.9 squared is the same thing as 9/10 squared, you could have actually gone 9 over 10 times 9 over 10 and got 81 hundredths, which would have let you then write it as a decimal, 81 hundredths. You could have done it that way if you wanted to. And you still would have figured out that 0.9 squared is less than 1, and therefore the answer is false. Okay, that was 7 minutes. Here we go. Next questions. These are all your standard square roots you should know. In fact, the first 3 are kind of mandatory. The square root of 64 means what number multiplied by itself is 64? The answer is 8. The square root of 169. We knew our perfect squares. We went 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, so therefore the square root of 169 is 13. 14 times 14 is the opposite. You reverse it, 196. 15 times 15 is 225, so therefore the square root of 225 is 15. And then we start getting into the decimals, and like, oh God, 0.04. If you read it as 0.04, you'll never get the answer. But if you know that says the square root of 4 hundredths, tenths, hundredths, then you write it as a fraction, because you can't do decimals. Fractions are so much easier. What fraction times itself? What fraction times itself is 4 over 100? It is 2 and 10, which is 2/10. But because my question was a decimal, I got to translate that fraction back to a decimal, and therefore the square root of 4 hundredths is 2/10. Same thing with 36 as a decimal, so 36 hundredths would mean 6/10 times 6/10. So the square root in fraction form is 6/10. In decimal form, 6/10. 1 over 10 times 1 over 10 is 1 over 100. So therefore 1/10 is the square root, or, oh sorry, I guess 1 square. Fraction question. 1/10 is your answer. What fraction times itself is 121 over 400? Numerator, 11 times 11 is 121. 20 times 20 is 400. Therefore, the square root is 11/20. Question 12. Your brain's saying, uh-oh, he said something about mixed fractions. Oh yeah, I can't do them. That's right. So the first thing you need to do is change this to improper. 4 times 2 is 8, plus 1 is 9. That's the same question, keeping in mind equivalency, mixed fraction, improper fraction. They're the same number. One's easier to work with. Which one? The improper fraction. What's your numerator? Your numerator will be 3. Your denominator will be 2. Therefore, the square root of this is this. But since we are dealing with mixed fractions, it's important that we put our answer. We change 3 over 2 back to mixed, which is 1 1/2. That's your answer. Square root of 2 1/4 is 1 1/2. Question 13, 3 and 1/16, a mixed fraction, bad. 16 times 3 is 48 plus 1 is 49. So therefore, it's 7 over 4 times 7 over 4, or 7/4 is the square root. But 7/4 as a mixed fraction is 1 3/4. So therefore, 1 3/4 is the square root of 3 and 1/16. A lot of people struggle with 14 and they didn't know their place value. First place value is called the tenths, the hundredths, thousandths, the 10,000ths. You have to read this as 1/10,000th. And if you don't, forget it, you can't do this question. Once you know your place value, which I think you learned in grade 5, I'm not sure, something like that, then 1/10,000th becomes really easy to write as a fraction. That's the same question. Square root of 1/10,000th as a decimal, square root of 1 10,000th as a fraction. Then what fraction times itself is 1 over 10,000? 1 times 1, 100 times 100. Therefore, the square root of 1/10,000th as a fraction is 100th. But as a decimal, more importantly, is 100th. And finally, the last one, square root of 900. It was just a question I asked because I wanted to see if you could rationalize it out. What number times itself? What number times itself is 900? The answer is 30 times 30. So the square root of 900 is 30. Or reverse, if I wanted to reverse it, 30 squared is 900. Questions 16 through 23 are now reversing it. Instead of doing square roots, we're just doing squaring. So what I advise you to do if you struggle with it, just write down what squaring means. Remember, whatever number this is called the base. When you square it, you multiply it by itself. 19 times 19 is 361. It's the one you had to memorize. You had to memorize up to 20 times 20, which is 17. So if you struggle, write this down, and then you have the answer of 400. 15 times 15 is what this means, which is 225. And 50 times 50, somebody said, I don't know how to do that. When you multiply numbers like 50 or 60 or 70, you just do 5 times 5 first, which is 25, and then add that many zeros. So if you want to quickly do a mental math calculation of 50 times 50, just do 5 times 5 and add 2 zeros, 2,500. 1.1 times 2, or squared, sorry. So think of it without decimals, which is 121, right? And then you ask yourself, how many decimals were there? There was 1. You double it when you square it, so you put 2 in. Your final answer will be 1.21. Question 21 is 0.5 squared, which is 0.5 times 0.5. Again, same rule. If you think about it, you're going to ignore the decimal and just do 5 times 5, which is 25. Okay, that's step 1. 1 decimal place is what you had in your actual squaring. You double it for 2 decimal places, which means you put 2 decimal places in your answer, you get 0.25 as the square of 0.5. Okay? Just to say that again, I'll just reverse. I'll just do that one more time so in case you didn't catch it all. When you have decimal 5 squared, drop the decimals. Think of it this way. Get 25. Think about how many decimal places you had. You had 1. Double it. You have 2. So it goes from here. You take that decimal and move it once, twice. You get 0.25 as your answer. Question 22 and 23 are really easy. 1/9 squared means 1/9 multiplied by itself twice, just like this. Which, since it's really only a grade 8 question with multiplication of fractions, your answer is 181st, 185th. I don't even know how to say that. When you have mixed fractions, just like the rest of our mixed fractions, they're very difficult to do. But since this question as an improper fraction base is this, that's much easier to do instead of 1 1/2. You will then have 3 over 2 times 3 over 2, which is 9 over 4 as an answer. This is what it would be if it was an improper fraction. But a good citizen would know that since the question was really a mixed fraction squared, I'm going to take my answer and ask myself, what is 9/4 as a mixed fraction? The answer is 2 and 1 over 4, which is going to be your final answer. Even though both answers are right, if you said 9/4, that's right, but never leave your answer as an improper fraction. 24 and 25, 26 and 27 are all estimation. The square root of 50, remember when you have it, I even told you that you need a number line because I drew it for you. You're going to put these two perfect squares, the two that you know. Square root of 49, which is 7, and the square root of 64, which is 8. And right off the bat, you know that the square root of 50 is going to fit in that yellow zone somewhere, which means since every number on that number line is 7 decimal something, you know, without even thinking right now, I can actually put 7 decimal. And I know that's going to be true. Everything about it, because every number on that number line between the square root of 49 to the square root of 64 is going to be 7 decimal something. My only question is I need to figure out what is that decimal. Since the square root of 50 is really darn close to the square root of 49, on my number line, that decimal seems appropriate right there. And then I can kind of say, well, what number is it? 7 decimal what? And I'd say 7 decimal 1 is a fairly good guess. It's probably 7 decimal 0, 8 or something like that. I don't know. But remember, we're estimating. So your answer is just approximately 7 decimal 1. And it doesn't matter if it's exact. You just have to tell me what it is based on your calculation. The square root of 200 will fit between the square root of 196, which is 14, and the square root of 225, which is 15. Again, you have to know your first 20 perfect squares. So on your cheat sheet that you're allowed to bring to your test, that would be important. And if I think about this, I have a number line between 14 and 15. I know right now, without doing any thinking, my answer is going to be 14 decimal something. And square root of 200 is really it's only 4 away from 196, and it's 25 away from 225. So that's a pretty good place. I'm still going to guess it's like 4 decimal 1 or 4 decimal 2. I'm going to guess, I don't know, let's go 4 decimal 2, just in case. Might be 4 decimal 1. Actually, let's just cheat for just a second. Let's just see. What is the square root of 200? 4 decimal 1, 4. Yeah. Okay, I was a little off. I was hemming and hawing between the two, but that's how you do it. Question 26, the square root of 68 hundredths. The two decimal perfect squares that you need to know are the square root of 0.64, which is 0.8, and the square root of 0.81, which is 0.9. So right now, I'm pretty sure it's between those two, but I'm going to add a 0 because Mr. McDonald said if you have two decimals that are close and you need to think about something between it, put an insignificant 0 down and think money. So right now, I can go, my answer is 0.8 something, right? Because all of those numbers between here and here will be 0.8 something, 0.81, 0.82, etc. If I think about where 0.8 or 68 will go, probably here, which means my estimation is approximately 0.83 for that one. And question 27, I made it complicated. I thought maybe it would be a good challenging question for people. Really what I wanted you to think of was this. The square root of 9 is 3. The square root of 16 is 4. The square root of 9 and 3/17, since the square root of 10, square root of 11, square root of 12, etc., this would probably be roughly the square root of 10, maybe a little bit closer, I don't know. The square root of 9 and 3/17 is right there, right? It's between the square root of 9 and the square root of 10. That's what I wanted you to think about. So therefore, a good estimation would be 3.1 or 3.05. I actually don't even know what it was, but I was hoping you'd put down 3.1. Okay. And your last question says my dining room is 4.5 meters by 3.5 meters. So before I even read the rest, I'm just going to draw my dining room. I'm going to say it's my dining room. And it is 2 words. Mr. McNeil told me it's 2 words, so I made a mistake. So it's 4.5 meters by 3.5 meters. Good stuff. My square table takes up 3/10 of the total area. Oh, let's draw a square table. And it's 3/10 of the area. 3/10 of the area. Of the area of the room. I'll just put 3/10 of the area. What is the length of the table? So then I'm going to put a question mark here. I want to know the length or the side length of the table. That's my question. So before I start doing any math, I draw my picture. All the information seems reasonable. Oh, I forgot to say table. I'll put table here because now you know it's a table. A very well drawn table. So your first step is probably, well, what is the area of the room? What is the total area of the room? And we know that since it's a rectangle, I always start with my formula. Area equals length times width. Area equals the length, which is 4.5, multiplied by the width, which is 3.5. There we go. So now we're off to something. We're almost there. And since with the story problems, you can use your calculator finally, 4.5 times 3.5 is 15.75. Now look, What you now need to do is put your units. And this is the area of the room. And if you want, you might even write it down in words because it's going to help you kind of remember what you just calculated. That's the area of the room. Now, step one is that. Step two is I don't know the area of the table, but I do know this fact about it, that it's 3/10 of the total area of the room, because it told me that. So really, if I bring down a little arrow here and say the table's area is 3/10 of the room area, if I write it in word form first just to kind of get my head around it, I'm like, oh, I can do this. This is a piece of cake. 3/10 is a decimal. Of, I know from 1,000 times of Mr. McDonald harping at me, is the word, it's multiplication. And since the room area was calculated by me, it all makes sense now. This will be able to calculate the area of the square table. This will be the area of the square table. Right, if I calculate this all up. So again, I grab my calculator. 30% or 3/10 of the area of the room is 4.75. Sorry, that's not what I said. 4.725. And this is the area of the table. So I'm going to go back in with an eraser real quick. It's no longer unknown. It is now known. The area of this table is 4.725 square meters. Wow, I'm getting something. But hold on. The last question, I put a question mark here because I don't need to know the area of the table. I need to know the side length. And since the table is a square, the area of a table equals side squared. Or since the area is 4.725 square meters, I'm able to isolate the variable here to figure out what is the side length, which is what my goal is. Square to side squared, the square root of this should work. S is isolated, and all I have to do is grab my calculator, ask it, calculator, what is the square root of this number? And press the square root button, and it says roughly 2.2. Just like that. So that I can take my question mark, say it's approximately 2.2, and therefore the length of the table is 2.2 meters. Easy peasy lemon squeezy. Now be careful, some people make the mistake of saying 2.2 meters squared is the length. 2 meters squared is a unit used for area, not for length. Length is measured in simple meters, distance, right? So make sure you don't confuse your area units with your distance units. And finally, your last question says a square picture has an area of 280 centimeters. So look, I'm going to put a square picture. I'll draw it of me because I'm handsome. The area equals 280 centimeters squared. And then a matte border is one, so I'm going to make a border, which is just a white thing I'm going to mount that picture onto, that is 1.5 times bigger. If the picture is centered in the mat, how wide would the border be? Well, right off the bat, I'm thinking to myself, I think I need this area here. I know that the area of this is 280, and I know that this is 1.5 times bigger. So the area is going to be 1.5 times bigger than the area of the picture, and therefore this is going to represent the area of the white mat. I don't think I need a calculator. I think it's 420, but I better just do it in case. 280 multiplied by 1.5 equals 420. So the area of this mat is 420 centimeters squared. Okay, so I got my picture area, I got my mat area, and I'm like, okay, I'm making something happen here. This is working. Now I got to draw one more picture. Mat. There's the mat. There's the picture, centered perfectly in the middle of the mat. Okay? I'm like, oh, what do I need? I only have area. You know what? I think I'm going to calculate the side length of each. So since this is 280, the square root of 280 will be the side length. Grab my calculator. What is the square root of 280? It's 16.7. So that's the length of the picture, approximately 16.7. Ooh, that's helpful. Put that here. Then the length of the border will be the square root of 420. Square root, you get 20.5. I'm going to round that up one decimal place. 20.5. Ooh, that's useful. I'm going to write that down here. And how wide would the white border be? is asking me what is this width here. That's really what we're looking for, correct? And that's going to take a little bit of thinking, a little bit of thunking. If I think about a black line that I'm going to draw here, that black line, I'm going to use x's too. That black line will be x plus 16.7 plus x equals 20.5. If you think of it that way, that makes sense. This distance, x, since x and x are the same distance, I can use it twice. X plus this is the same distance as this. That makes a whole lot of sense, right? And if I solve it algebraically, an x plus an x is actually 2x. And I don't expect you to do it this way. I'm going to show you how to logically do it this way with algebra, and then you could do it however way you want, but I'm going to show you this way. If I subtract 16.7 from both sides, algebraically speaking, I end up with two of these x's, an x here and an x here, is going to equal the difference of those two, which is going to be 3.8, I think. I better make sure that's right. Grab a calculator, 20.5, take away 16.7 equals 3.8, good. And if two of them is 3.8, so this distance here and this distance here have to make up the residual, which is 3.8 centimeters. Then if I divide that by 2, my x is going to be 1.9 centimeters wide. So this x, or this distance here, is 1.9 centimeters, which means, therefore, the width of the border I spelled border with an A, is 1.9 centimeters. Okay. There's a lot of work there, a lot of work. If you're making a cheat sheet, probably a good idea to kind of maybe draw this picture. This picture would kind of help you maybe. Maybe, I don't know. If you have room on it, it's only a small little space, but figure out what's important. Practice it a couple times, maybe you get it. And good luck on your test.